One mango, two experienced sellers. Same fruit, opposite answers. One says, sell it today. The other says, wait. If humans cannot write one perfect rule, how could a machine ever learn the judgment? Do not answer yet. First, build the machine with me. Imagine you run a mango shop. Every morning, hundreds of mangoes arrive. Some are ready to sell. Some need another day. Sorting every fruit by hand is slow. So you ask, can a machine look at a mango and decide whether it is ready? If you had never heard of machine learning, what would you build? Let us start with the most obvious idea. A seller judges the fruit, so we turn that judgment into instructions. Perhaps a ripe mango is yellow. We give the machine one rule. If yellowness is above 70, say ready. It works for this mango. And this one. Now a third mango arrives. What will the machine say? Now test the rule on reality. This mango is green, yet perfectly ripe inside. Our rule says, wait. This yellow mango looks ready, but damage has spread through it. Our rule says, ready. So we add softness, then smell, then wait. Soon, the simple rule becomes a forest of exceptions. The machine may be useful, but did it learn? No. When reality surprised it, the machine did not change. We changed the instructions. It followed more rules. Complexity alone does not turn instructions into learning. What if we show the machine every mango we have already judged? It stores the color, softness, weight, and our answer. When an identical mango appears, it remembers the result. That feels closer. It has experience. But now, place a mango in front of it that it has never seen before. Not identical to any memory. Slightly greener than one, softer than another. Memory can tell us what happened before. Our problem asks what to do now. Exact memorization is not enough. The machine must use old experience to change how it responds to a new case. That sentence contains the breakthrough. Let us give the machine something adjustable. Instead of a permanent boundary, yellow above 70, give it a boundary that can move. The machine sees a mango and makes a prediction. Then we reveal the correct answer. If the prediction was wrong, it shifts the boundary a little. The next mango is judged using the changed boundary. Experience has altered future behavior. That is the minimum idea of learning. Not magic, not consciousness. An adjustable system uses experience to change how it responds later. The adjustable system is called a model. The clues we give it, color, softness, and weight, are features. Its answer is a prediction. The correct answer is the label or outcome. The difference between them is an error. Using that error to adjust the model is training. The names arrived last. You already owned the ideas. Here is the whole loop: experience, prediction, feedback, adjustment. Then another prediction. If the adjustment helps on future mangoes, the machine is learning something useful. Notice the word future. A machine can become perfect at the examples it remembers and still fail everywhere else. The real test is a mango hidden during training. The model has never seen this exact fruit. yet the pattern it formed gives a reasonable answer. Using experience beyond the exact examples is called generalization. That is the difference between reciting yesterday's answers and carrying an idea into tomorrow. But feedback does not guarantee wisdom. Suppose every small mango in our examples happened to be unripe. The machine may learn that size means readiness, even when size is only an accident of our sample. Suppose we label ripe green mangoes as unripe. The machine faithfully learns our mistake. Suppose tomorrow's mangoes come from a different region. The pattern that worked yesterday may no longer work. A learning machine does not discover truth automatically. It changes according to the experience, target, and feedback we provide. Learning can be useful, useless, biased, or wrong. Now test the idea somewhere else. A spam filter with 1,000 handcrafted if rules. Sophisticated, perhaps, but rule following. A system that stores every old email and only recognizes exact copies. Memorization. A filter that predicts, receives corrections, adjusts, and improves on new emails. Learning. A video app that changes recommendations after observing what you watch may be learning a pattern in your behavior. Whether that pattern serves you is a different question. You can now look past the word AI and ask for evidence. What was the experience? What prediction was made? What feedback arrived? What changed? Did the change help on a new case? So, can a machine actually learn? Yes, but we should mean something precise. A machine learns when experience changes its internal model in a way that changes future behavior. Useful learning goes one step further. That change helps on cases it did not merely memorize. Rules act. Memory recalls. Learning adjusts and generalizes. We began with the mango and ended with a test you can apply to any claimed AI system. But our machine has only made a yes or no decision, ready or not ready. What if the answer is a number? What price should this mango have? How many will sell tomorrow? How long before it ripens? In the next rediscovery, we will ask, how can a machine make a guess? If this is how you want to learn AI, subscribe and join us. Like the video, so more curious minds can find the series. And tell us in the comments what clicked, what was unclear, and what we should improve. Your feedback will shape the episodes that follow.